Andy Kamashian, Southern Fabricating Machinery Sales. Today we're going to talk about lasers, and I'm not talking about the stuff that you saw at the Blue Oyster Cult concert. Hi, Andy. How are you?
Doing good, David. How are you?
I'm really good. Let's talk about lasers. What's the deal with a laser? What are they used for?
Well, lasers are one of the first processes in a sheet metal fabricating shop. We get a sheet of material that comes in, and we've got to cut that up into shapes that we're going to use for other down the road for forming and fabricating, for welding, and before we can get it there, we've got to get that part cut up. And lasers can do so much. So what we use that laser for is to cut shapes. There are other processes to cut shapes, but lasers are just so efficient at what they're doing. We can bring that material right in and cut up that flat sheet of material into just about any shape with all the holes and details, extremely fine details, to a part accuracy that's really second to none.
How does it differ from it's going to be another topic in another show, but water jets? I mean, what's the difference between those two other than the fact that it's using light instead of water? How are they better applied, laser?
Water jets sit on one end of we'll call it a seesaw. There's a balancing seesaw out there. Water jets sit on the end of that seesaw that's about capability, all about capability. Water jets can cut anything you can touch. They don't cut everything very well. Lasers sit on the other end of the seesaw that's all about capacity. I can cut a lot of what I can fit into that range of laser cutting. And so that's 3/8 steel, 1/4 inch steel. Most of the applications for a metal fab shop, a laser is just going to devour that at an enormous rate at a very low cost.
Sheet metal shearing is limited to straight lines, and a laser can obviously cut that straight line. But about a 1/2 inch is where you're going to cut off at a shear, correct?
About a 1/2 inch. There are shears that are made up to 1 inch, but very, very few and far between today.
How thick do lasers cut?
Lasers can go all the way up to 2 inches and above, but
that's a big piece of steel, man.
Effectively, it's typically 1 inch and under, with the main range around 1/2 inch to 5/8 is where we typically see laser cutting.
What is a CO2 laser? And where are those used?
Well, CO2 was the original development of laser technology, and it was the way that the laser beam was developed within this what we called a resonator. There was a lot of lased gases in there, high-speed turbo, and we used radio frequency to actually bounce light off of each other, break it up into more and more pieces, these little ions of light. And so that CO2 created and amplified the actual laser, and then we used a beam path delivery system to bounce that all the way around to the cutting head. Quite complex design, a lot of maintenance, very expensive, and there was a shelf life for those resonators. They did have an advantage over the newer technology today of fiber, although that's slipping away, and that was they were a little more forgiving on the types of materials and the conditions of materials that they cut into. Some hot rolled materials, scaly surfaces, a variety of different materials, but they didn't like reflective materials at all. Today's CO2 lasers, for the most part, are going away. There's still some applications for them, but for the most part, the technology in fiber lasers has caught up and is surpassing that of CO2s.
So before we leave CO2, I'm an appraiser. I see a CO2 laser, and I know it's a CO2 laser because it's got all those big black boxes that come over to the head. That's where the mirrors are, right?
Yeah, where the mirrors and where the turbos and
big table, big cutting table, and this thing moves around and looks super expensive. Has it got any value?
It has value. CO2 lasers today do have value. They are dropping in value as more and more fiber lasers come out, especially some from the Far East. We see some of those technologies come out, but there are a few applications where CO2 lasers are preferred over fiber lasers.
Fiber lasers. What's that? That's the newest, right? The fiber laser's the latest and greatest?
Correct. So in the past with CO2 lasers, we had a very complex way that we developed the laser inside that resonator. A lot of things going on, a lot of gases, a lot of components to replace and repair and maintain, a lot of expenses with that. And of course, a lot of skill required to maintain that laser. With fiber lasers, we're generating the laser itself typically with a solid state, we'll call it a resonator, it's not really, but a solid state box that looks very much like a transformer. No moving parts, no consumables, nothing to replace, inside this box. And it's fed, instead of through a complex beam delivery system, it's fed through a fiber optic cable, just like your internet is to your home. And that fiber optic cable is very flexible, very easy to use, very easy to install, and requires no maintenance. So there's so much that was just removed from the operator and the owner's requirements when they went to fiber. And as fiber technology is getting better and better, we're getting better at cutting other materials and being able to cut some of the more tougher things that CO2 used to have an edge on.
So the difference is almost like those, this isn't a flashlight, but those new flashlights that you get with those, they don't even have light bulbs in them. They've got these solid state little chips and they send out so much light, they're 1,000 times brighter than any incandescent bulb would be. Is that a reasonable comparison, or am I off base with that?
It's a reasonable comparison. There's so far we don't even really have a shelf life for fiber laser resonators. It used to be that we had with CO2 machines, we looked at these things as a 50,000 hour shelf life, that after 50,000 hours, we'd have to, pull this thing out and do a complete refurb, rebuild, or replacement of the resonator. Some of those resonators went to 100,000 hours. And again, we were putting in 17, 18,000 a year into these resonators to keep them going and keep them efficient. And now we've got these fiber laser resonators, these solid state transformer looking boxes with no moving parts, no replaceables. And we just really don't know how long that they're going to last. But we're seeing in plant real time expectations of 15 plus years. And it's just phenomenal. So we're seeing these lasers last longer, cost less, and that's also impacting that used laser market as well.
I would say all about lasers. It sounds to me like the fiber laser is the way that things are moving, and that the CO2 laser is going to be moving aside, almost like the mechanical press brake did.
I think so.
At some point. Andy Kamashian, Southern Fabricating Machinery Sales, the expert. I appreciate your time today.
Thank you.